This is how to wire an electric shower, the highest current circuit in the whole house. One dedicated breaker at the consumer unit. One heavy cable. A double pole pull cord isolator on the ceiling. And the shower unit itself. No plug, no socket. A fixed, dedicated circuit all its own. Get the breaker, the cable, and the isolator sized right, and it is simple. Get them wrong, and it overheats. Let me walk the whole circuit. So why does an electric shower get its own special treatment? Because it is the biggest single load in a normal home. A kettle pulls 13 amps. An electric shower pulls 37, 41, even 46 amps every second it runs. That much current needs its own dedicated circuit, straight from the consumer unit. You never share it, never spur off it, and never put on a plug. A 13-amp socket would melt. And because it lives in a bathroom, water and mains in the same room, it carries the strictest safety rules in the house. A residual current device is not optional here. It is mandatory. We will come back to that because it is the part that keeps you alive. One quick note before the circuit. Everything I draw here is in a free browser editor. No install, no sign up. It is at CircuitDiagramMaker.app, and the link is in the description. Open it and follow along. Start at the consumer unit, because everything is sized off the shower's power rating. Your shower has a kilowatt number stamped on it, and that number sets the breaker. Here is the rule of thumb. An 8.5 kilowatt shower pulls about 37 amps, so it wants a 40 amp breaker. A 9.5 kilowatt shower pulls about 41 amps, a 45 amp breaker. And a 10.5 kilowatt shower pulls about 46 amps, a 50 amp breaker. So it is a dedicated breaker, sized to the shower, a 40, a 45, or a 50 amp MCB, on its own way in the consumer unit. Not shared with the lights. Not shared with the sockets. Its own circuit start to finish. Check your shower's rating plate first. Everything downstream, the cable, the isolator, sizes off that breaker. Now the cable. And this is where people cut corners and pay for it. For most modern showers, that means 10 millimeter squared cable. 10 mil carries the current of a 45 or 50 amp circuit without cooking itself, even bundled in insulation or run through a warm loft. 6 millimeter squared only works for the smaller showers on a short run. An 8.5 kilowatt unit close to the board. Go bigger or run it far, and 6 mil runs hot. This is the whole reason cable sizing matters. Undersized cable is a fire waiting to happen. It carries current fine for a minute, then the insulation warms, then it fails. When in doubt, go up to 10 mil, match the cable to the breaker and the breaker to the shower. Between the board and the shower sits the one part people always ask about, the pull cord isolator switch. It mounts on the ceiling outside the shower zone, worked by a cord so wet hands never touch a switch. And it must be a double pole switch, rated 45 or 50 amps to match the circuit. Double pole is the key word. It breaks both the live and the neutral at once. So when you pull that cord, the shower is fully dead, not just switched off on one leg, but isolated on both. That is what lets someone service the shower safely. Most of these have a little neon that glows when the power is on, and a satisfying mechanical on-off. Cord down, power on. Cord down again, power off. Both poles broken. Line in from the breaker, load out to the shower. And finally, the shower unit itself. Pop the cover, and you find a terminal block with 3 connections. Live, neutral, and earth. The 10 mil cable from the isolator lands right there, brown to live, blue to neutral, and the earth to the earth terminal. That earth is not decoration. Bond it properly, and if a fault ever puts live onto the metal casing, the earth carries it away and trips the breaker instead of you. Live, neutral, earth, 3 wires landed tight, cover back on. Now the safety, because a shower circuit is not a place to guess. First, and non-negotiable, a residual current device, 30 milliamps, protecting this circuit. It is a bathroom, and an RCD is mandatory. It watches the live and neutral, and the instant a few milliamps leak through a fault, through a person, it cuts the power in a fraction of a second. That is the device that turns a lethal shock into a trip. Second, bathroom zones and supplementary bonding. The room is divided into zones by how close you are to the water, and the metalwork gets bonded together so nothing can sit at a different voltage. Your shower sits outside the splash zones for a reason. And say it with me: no plug, no socket. It is a fixed, dedicated circuit. To work on it, isolate at the pull cord and at the consumer unit, prove it is dead, and if you're not qualified, get it inspected and signed off. So here is the whole electric shower circuit on one sheet. Dedicated breaker at the consumer unit, size to the shower's kilowatts. 10mm cable out to a double pull cord isolator on the ceiling. Then down to the shower's terminal block, live, neutral, earth, and the RCD watching over all of it. Follow any wire end to end, and the whole circuit reads clean. Now let us lay one out from scratch in the editor. Blank canvas. I search the symbol library and tap parts onto the grid. A breaker for the dedicated way in the consumer unit. A switch standing in for the double pole isolator. A box standing in for the shower unit. And a ground for the earth. These come from the free do-it-yourself pack the guest editor gives you. A dedicated shower and pull cord symbol lives on the paid tier. But these shapes are enough to lay out the circuit. Then the wires. Press W, click one pin, click the next, and the wire snaps in with square corners. Move apart, and every wire follows. And here is something a plain drawing tool cannot do. Simulate it. There is a genuine circuit engine inside the page. Hit Simulate, choose the operating point, and run it. Live voltages and currents land right on the wires, so you can check the path is continuous before a single core gets stripped. On a circuit that carries 40+ amps, checking the layout first is not fussy. It is sensible. When the drawing is done, it has to leave the screen. One click opens the export menu. PNG is free, good enough to drop into a job sheet, or a group chat with whoever is doing the install. Vector formats, PDF, SVG, and DXF sit on the paid plans. That is the honest business model, said plainly. This tool is ours. 4 clean wiring and schematic drawings you can share and mark up. It is genuinely good and free to start. One last thing, because the shower is only one circuit in the house. The same consumer unit feeds every other circuit, the sockets, the lights, the cooker. If you want to see how the whole board is wired, there is a consumer unit wiring diagram linked in the description on the same free editor. Draw the shower here, then see where it sits in the whole house. So that is an electric shower, start to finish. A dedicated breaker, size of the shower's kilowatts, 40, 45, or 50 amps. 10mm cable, up from 6 only on the smallest short runs. A double pull cord isolator that breaks live and neutral both. Live, neutral, and earth to the shower. And a 30 milliamp RCD over all of it because it is a bathroom. Open the free editor and lay out your own. It is at CircuitDiagramMaker.app. No install, no card. Subscribe for a new wiring video every week. See you in the next one.